This is the review for the test we'll be having on Friday over prime factorization, greatest common factor, and least common multiple. The first thing on the test will be prime factorization, and we need to be able to take a large number like 484 and break it down into its prime factors. That's when we use the factor tree. So we write down our number, and we think of a factor pair, any factor pair that can work for that number. Now this is a large number and I don't have its factor pairs memorized, which means I'm going to have to try out some different numbers. I can see, because it ends in a 4, that it's an even number, which means it must be 2 times something. So I come over to the side and figure out what that something is by dividing. So 484 divided by 2. 2 goes into 4 2 times. Bring it down. 2 goes into 8 4 times. Bring down my 4. 2 goes into 4 2 times. I get no remainder, which tells me yes, dividing by 2 does work. So it's 2 times 242. Now when I'm doing a prime factorization, I'm trying to break the numbers down into their prime factors. So I have to check each one. 2 is a prime factor, so I'm going to circle it. 242 is not a prime factor, so I need to break it down again. And once again I can see it ends in 2, which means I can divide by 2. If it didn't end by 2, I might try a different number like dividing by 3. So I'm going to try that. So 242 divided by 3. 3 goes into 24 8 times. Bring down my 2, and 3 does not go into 2, so 3 did not work. So I'll try the 2. 242 divided by 2. 2 goes into 2 one time. 2 goes into 4 twice. And 2 goes into 2 once. So it's 2 times 121. So I put that into my prime factorization. 2 is prime, so I circle it. 121 is not prime, so I need to break it down. And 121 is a tough one because it's actually 11 times 11. And 11 is a prime number. Now at the very end, I take all these numbers that I have circled and I write them as a multiplication problem. 2 times 2 times 11 times 11. And I also need to be able to write those with exponents. So the first factor that I have is 2. So that's going to be the big number. And then I count how many there are. 1, 2. Okay? And then the next factor I have is 11. And I also have 2 of those. So the prime factorization of 484 is 2 squared times 11 squared. Now, the important thing about prime factorization is that we kept breaking that number down until we got all prime numbers. So a question like this, what is the greatest prime factor of 84? I am only looking for numbers that are prime numbers. So when I look at my answer choices, I can tell right away it cannot be A and it cannot be D, because those are composite numbers. So it has to be 7 or 2. 7 is the larger of the 2. So if it works, that's going to be my answer. But I need to check it. So I take 84 and divide it by 7. 7 goes into 8 one time. 1 left over. 7 goes into 14 twice. So 7 is a factor of 84, and it's a prime factor. So B would be my answer. I'm going to use my same reasoning on this question. Which of the following is not a prime factorization? If it does not have prime numbers, it is not a prime factorization. And when I check all of the factors in these problems, I find one that's composite. Can you see it? That's right. The composite number is this 9 right here. That means this is not a prime factorization. So C is the answer. We also need to be able to work backwards. 2 cubed times 5 squared is the prime factorization of what number? The important thing to do is to stretch this out into its factor form first. So I'm going to write all the factors out. 2 times 2 times 2. I wrote it 3 times because that's what the exponent was. And then I need to write 5 2 times. Okay. Then I'm going to do kind of a backwards factor tree to multiply them. And I can multiply them in any order that I want to. So 2 times 2 is 4. And 2 times 5 is 10. 4 times 10 is 40. And then 40 times 5, well, 4 times 5 is 20 plus an extra 0. So the answer is 200. When I put it into my griddable, here's my decimal point, which means the whole numbers are on this side. So I'm going to write the 200 right here. And then, of course, I need to bubble it in. I do not need to bubble in the columns that I do not use. And that's the end of part 1 of our review.